All right, good morning, everybody. Nice seeing you all. So today we're gonna review exponents. So our whole next unit is over radicals. Radicals, probably the one you know of most is the square root. And so the square root is nothing more, or I should say any radical is nothing more than an exponent. And so in Algebra 1, you guys learn how to work with exponents. You went through many rules. So you talked about what do you do when you have product of powers? So how do you combine those? You also talked in Algebra 1, what happens when you have a power to a power? It looks like this. So what do you do when you have x to the 5th to the 9th? Do you add the 5 and the 9? Do you multiply? Do you subtract? What do you do? Power of a product. Okay, so these rules are listed here, and these are from Algebra 1. So we're going to go through some of these relatively fast because it's review. And really, exponents, you're not going to be tested over the property of exponents, but you will be expected to know how to use the properties when we deal with radicals. So I figured spending a day reviewing this would be beneficial. So the first thing we want to talk about is the product of powers. And that says if you have the same base and you're raising them to different exponents, just add the exponents together. So notice they have the same base, x and x. Okay, I still take 5 times 1. That's a 1x to the 6. I get 5. But now, because they're the same base, x and x, you just take 7 plus 6, and that's 13. So you get 5x to the 13th. Here, 3 times negative 12 is negative 36. And then you have the same base, r and r. R to the 4th times r to the 3rd. Again, you add the exponents. That'd be r to the 7th. Here, 6 times 5 is 30, and we're multiplying because this is in parentheses. 6 times 5 is 30. C times c squared, remember that's like c to the 1st. So that's 1 plus 2 is 3, so I put c to the 3rd. And then d to the 5th, d to the 2nd, we're multiplying. So you add the exponents, that would be d to the 7th. So that is a review of the product of powers rule for exponents. Now let's talk about what happens when you have a power raised to a power. Well, the rule is right here. You just multiply the powers. So 5 times 9 is 45. Here, 3 times 3 times 2. So we have 3 powers. We just multiply all 3. 3 times 3 is 9, times 2 is 18. So that's 2 to the 18th. And then here, 4 times 5 is 20. All right, what happens if you have 2, if anything, raised to an exponent? Well, you just raise everything inside to that exponent. And so like here, we have 2x squared y raised to the 4th. So we're going to raise the 2 to the 4th, the x squared to the 4th, the y to the 4th. 2 to the 4th, which I could simplify. 2 times 2 is 4, times 2 is 8, times 2 is 16. Then we're going to take x squared to the 4th, which we could use the rule we just learned about or reviewed, power of a power. 2 times 4 is 8. And then finally, y to the 4th. Nothing special about that. Will just be y to the 4th. So that's how you do power of a product. I don't know if we'll go through every single one of these problems. I just want to review with you guys. Here, we're going to raise 8 to the third, g to the third to the third, h squared to the third. 8 to the third, 8 times 8 times 8. That is 512. And then g to the third, remember, you multiply power to power. So 3 times 3 is 9. That'd be g to the ninth. And then h squared to the third, you multiply. That'd be h to the sixth. And then we're going to do 5 to the fourth. 5 times 5 is 25, times 5 is 125. Let's see, what's 5 to the fourth? 5 to the fourth is 625. G squared to the fourth, you multiply the exponents. 2 times 4 is 8. H squared to the fourth, you multiply the exponent. 2 times 4 is 8. And now we have a product times a product. So I take 512 times 625. And that is 320,000. G to the ninth times g to the eighth. Remember, when you multiply and you have the same base, you add the exponent. 9 plus 8 is 17. And then 6 plus 8 is 14. Okay, so as you can see, it's very, very handy to know how to work with exponents. Here, 9 squared is 81. H squared squared, 2 times 2 is 4. And then 4 times 2 is 8. Okay, so all of this should be reviewed from Algebra 1. Next, what happens when you have a quotient? Quotient means division. Usually we write division as a fraction. So what you do is you just take m minus n. So you take m minus n. So if you have the same base, you just subtract the exponents. 9 minus 4 is 5. 3 minus 1, because that's x to the 1, that's x squared. 8 minus 2 is 6. 5 minus 2 is 3. 9 minus 4 is 5. The only thing I ask is that you make sure that you can't combine the C's. If this was a C and this was a D, you couldn't subtract. They have to be the same base. Okay, so that's what you do when you have division. Interestingly enough, anything to the 0 power is 1. So if you raise anything to the 0, you get 1. So this equals 1. You're raising all of this to the 0, that's equal to 1. Now here, s to the 0 is 1. Okay, so this is really t cubed times 1, which you don't really need times 1. So you just take 3 minus your 1 and you get t squared. The s went away because s to the 0 is 1. What do you do when you have a negative exponent? If you have something raised to a negative power, just bring it down to the denominator. Same thing, if you have something in the denominator, just bring it up to the numerator. So 5 to the negative 2, we can write that as 1 over 5 to the positive 2. And 5 to the positive 2, 5 squared is 25, so that's 1 over 25. Let's see. There's many ways to do these problems. You could subtract, or you can move things up. It's the same thing. I think it's probably easier to move things. So like x to the negative fifth, I'm going to bring that up here to make it positive x to the fifth. And then the x to the fourth, y to the negative third will stay there. And then actually the y to the negative 3 I'm going to bring down here. Make it y to the positive 3. I already moved that up. And then y to the 8th is good, so we leave it down here. So long story short, if it's negative, bring it to the top, make it positive. If it's negative on top, bring it down to the bottom, make it positive. And then here we have 5 times x to the fifth times x to the fourth. Same base, you add the exponent. That'd be 5 plus 4 is 9. 8 plus 3 is 11. All right. Here, y to the 0 is 1. So I'm just going to cross that off because anything times 1 is itself. So it's away. 3 plus negative 7 is negative 4. We don't like negative exponents, so we're going to write that as 1 over x to the fourth. Next, and again, all of this should be reviewed from Algebra 1. If you have a quantity raised to a exponent, you raise each of those to that exponent. So like here, I would say x to the fifth divided by y to the fifth. And all I'm doing is following this rule right here. Here, I would probably move all of this down and move that all the way up, because then we could change that to the first. So anytime you have negative 1, you could just write the fraction or write everything opposite. So it was negative 1, but because I flipped the fraction, now it's positive 1. And you technically, anything raised to the first is itself. And then from there, I can see what we have going on. Let's see. N squared, n to the fourth. I'm going to subtract this way. 4 minus 2 is 2. So I'm going to have n squared on bottom. We could always subtract that way, 4 minus 2, and put that on bottom. If you want to go this way, 2 minus 4, that's negative 2, but then you're going to bring it down anyway. Let's see, z to the negative 3, I'm going to go ahead and bring down. Make it positive. The 5 is good, leave it there. And then the b, I'm going to bring up, make it b squared. And then I already did 4 minus 2, and you got 2. So this is the simplified form of that exponent. Here, again, I would write that as 2/3 to the third. And then 2 to the third, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So that's how you work with powers of a quotient. So here's all of the rules listed together in one big table in case you need them. These are more examples that I think we have time for. So number 1, 5 times negative 3, negative 15. A cubed times a to the negative 4, I add. Remember, when they're the same base, you add the exponents. So I'm going to go 3 plus negative 4 is negative 1. But when you have a negative exponent right here, you just bring it down to the denominator, make it a positive exponent. So I'm going to take this and bring it down and get 15 over a to the first, or you don't have to put a 1. You can, it's up to you. So 15 over a. Number 2, I have something raised to a power. So I have something raised to a power. You take each thing raised to that power. So I'm going to take -4 squared. -4 times -4 is 16. X to the -3 times 2. Remember, you multiply exponents. So it'll be -3 times 2 is -6. 2 times 2, I guess that's a 5. 5 times 2 is 10. And you don't like negative exponents, so you're going to drop it down to the denominator. I'm going to show you a different way you could do these. It might make it seem like more sense. So this, another way to write this would be 4a, 6b's, and then 3c's, 5a's, 1b, 3c's. Again, you don't have to do it this way, but for some kids it might help. So then you could look for things in common, like this has an A and an A, cross it off, but it has no more A's in common. This has a B and a B in common. This has 3 C's and 3 C's. Then you write down what's left over. So it'd be 4, and I count 1, 2, 3, 4, 5 B's. A, 1, 2, 3, 4, crossed off, and it's simplified. Now, I probably wouldn't do it that way unless you have to, but notice the 4 stays here. We did 5 minus 1. We got 4 A's, goes on the bottom. We did 6 minus 1 is 5, b to the 5th on top. And then 3 minus 3 is 0. Anything to the 0 is 1, so they go away. So if you want to list it out, you can. Number 4, remember, I could just flip this whole fraction if it's to a negative. So that's the same thing as b to the 3rd over 3 a squared b to the 1st. So if that was a -2, this would be a +2. If this is -3, it would be a +3. But to the 1st doesn't change anything. So now we get b to the 3rd, 3 a squared b. When we take our b's, we have 3 b's on top, 1 on bottom. 1 goes away. 3 minus 1 is 2. That leaves b squared on top. So I get b squared over 3a squared. On this one, I notice I have to the 0 power, so I'm going to cross that off. Because anything times this is 1, anything times 1 is itself. What else can I do? There's multiple ways to do this problem. Trying to decide which way I want to go. Let's see. I think I might just bring this down. So I'd get 2x cubed. So I always like to get rid of the negative exponents. That'd be 2x cubed times 3y And then 4y to the 7th times x cubed then I also have my x to the 4th that's coming down to make it positive. Okay. From there, 2 times 3 is 6. And I'll leave the 4 down here. X cubed over x cubed, those go away. Already did 2 times 3, 6. For the y, 7 minus 1 is 6. So that'd be y to the 6 down here. Already brought the 4 over. And then I have x to the 4th. Now we're almost done. 6 over 4 reduces to 3/2. So that equals 3 over 2y to the 6th, x to the 4th. So those are the properties of exponents. So let's get into a little bit in radicals and then we'll call it a day. So this is an exponent. 3 squared is 9. We say that 3 is the square root of 9, and we write it like this. Square root of 9 equals 3. Okay. 4 to the 3rd is 64. We say that 4 is the, we call it a cubed root. Cubed root just means to the 3rd power. And we write it like this. We would say the cubed root of 64 is 4. Notice to represent a cube, we put a 3 up here. It's called the index. And then 2 to the 4th is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. We say 2 is the 4th root of 16, and we write it like this. The 4th root of 16 is 2. Now, anytime they don't have anything up here in the index, we assume it's a 2. If they tell us that it's a 3, then it's a 3. And so they'll have a number up here, but if there's no number, we assume it's a 2. We don't really need to talk about that, I don't think. So some vocab, we call this number up here the index, it changes. We call this the radical symbol. And we call what's inside the radical the radicand. Okay. And so this is kind of getting us into the whole chapter, which is radicals. Anything with the odd roots are going to be positive if a is positive, and if a is negative, it's going to be negative. So here, what times what times what is 1,000. Well, 10 times 10 is 100, times 10 is 1,000, so that would be 10. What times what is negative 8? Well, that'd be negative 2. Negative 2 times negative 2 is 4, times negative 2 is negative 8. Okay. Now, so if you have an odd degree and a negative radicand, it's going to be negative. Now, if you have anything to an even index, like 2, 4, 6, the number inside the radicand must be positive. If it's not positive, then we say no solution. For example, square root of negative 49, you type that in, you cannot do anything even with the negative. It'll say error. So square root of negative 49, for now, you'll just say no real solution. We know what the imaginary solution is. We learned that in this class. That'd be 7i. Okay, positive and negative 7i. But we're not going to mess with imaginary in this unit. Square root of 100, well, that's easy, 10 times 10. Fourth root of 625. Some of these you might need to use a calculator. I can't think of what that would be. So on like this calculator, I know I go 4, and then math, and it's number 5. So that'll do the fourth root of 625, which is 5. In other words, if I take 5 times 5 times 5 times 5, I should get 625, and I do. So the fourth root of 625 is 5. And I'm sure, I bet Desmo's scientific calculator has that function. All right, so what I want you guys to do is to pick some of these. These are all different exponent type problems. I can't remember how many I said to pick out, but I definitely do not want you to do all of them. There's a note on the top of the page that says how many to pick out. This worksheet starts easy, it gets hard. I'll let you pick which ones you want to do. I would recommend doing some of the more challenging ones if you have time. But other than that, for today, we're just doing exponents. And then the next class period, we're going to do fractional exponents. So what do you do when you have like 5 to a half, 5 to a third, 5 to a fourth? And we're going to talk about fractional exponents. But that's all I have for today. Nice seeing you all. Have a great day.